Breaking news. There has been an accident involving a lorry carrying over 1,000 litres of hydrochloric acid. It is feared that some of the acid might have leaked into a nearby river upstream of a site of special scientific interest. Chemists are at the scene to assess the damage and work out how acidic the river has become. When an acid, for example hydrochloric acid, is mixed with water, it completely dissociates, producing a solution of hydrogen ions and chloride ions. Acids can be neutralized by substances called bases. Bases that are soluble in water are called alkalis. When an alkali, such as sodium hydroxide, is dissolved in water, it completely dissociates, so that all of the sodium ions and hydroxide ions are dispersed randomly in the solution. An acid and alkali react to form a salt and water. For example, sodium hydroxide and hydrochloric acid react to form sodium chloride and water. If we draw the dissolved compounds as ions, we can simplify the equation, leaving out the sodium ions and the chloride ions. They are known as spectator ions because they appear on both sides of the equation. When we have removed all the spectator ions, we are left with the net ionic equation, showing just the hydrogen ion and the hydroxide ion reacting to form a molecule of water. A concentration of a solution tells us the amount of a substance dissolved in a volume. It is measured in moles per cubic decimeter. We can determine the concentration of hydrogen ions in an acid solution by performing a titration experiment. As the acid is added to the alkali, the hydrogen ions react with hydroxide ions to form molecules of water. The end of the titration is when all of the alkali has reacted. At this point, the pH is neutral. We use an indicator compound which changes color when the point of neutralization is reached. In this example, the balanced equation shows that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. The amount of alkali can be calculated using the known concentration and volume of the alkali solution. The volume of acid that reacted can be read from the burette. It's good practice to repeat the titration and calculate the average volume added. We can now rearrange the equation to calculate the unknown concentration of acid. As part of the environmental response team, you will have to act quickly to assess the environmental impact of the acid spill and advise on an appropriate response to protect the site of special scientific interest. Samples from the contaminated river have been collected and transported back to the laboratory ready for you to test. In this activity, you will learn how to set up and run a titration experiment to calculate the unknown concentrations of acid in the samples collected from the contaminated river. You'll need to carefully add just the right amount of acid to the alkali solution to reach the neutralization point and judge when the indicator color changes.